Hi, in this video we will continue our robot setup. First we'll have to determine the position of the external table relative to the robot, and second we will go to ENCY's machine maker and make our digital twin. So right now I already have my robot in place right above this hole over here. I happen to have this hole, but not everyone has this, so I will explain different methods. So I selected my spindle TCP. I know that's exactly the middle of my milling motor. So I place this measurement tool over here and I know I'm exactly in the middle of this hole with this measurement tool. If you don't have this tool, you can also use the spike we used in the TCP video. For example, if you have a square fixed table, you can place this tip of the tool at the corner of your table, and then you can also read the position of that point, and then you can drag and drop that position in Machine Maker to that point. I will show you right in a moment how you can do this. So now we are in my KUKA KRC2 controller again. What I always want to do when measuring the external table, I go to Setup, Measure External Kinematic, Root Point, and then I just fill in 2 and then Tutorial. And then over here we need the spindle TCP. That's the one we need. Just continue, continue, and continue. Now it knows I'm measuring from my spindle TCP, and I just cancel this program. Then I go to Monitor, Robot Position Certain, and right now I have these values we want to fill in Machine Maker. Here we are, ENCY's Machine Maker. So first, you open this tab, and this is the online library or your local library. But today we will use the online library. For example, you have a KUKA KR240. You can add it like this, and here it is, your robot. But we don't have a KR240, we have a different one, and we will add it from the local library. You can click Add Mechanism, Robot, Robot 6-axis, and here it is, our robot. Now we have to define base and joints. So base, joint 1, and we will delete this part over here just with the delete button. Joint 2, joint 3, joint 5 and joint 6. Here it is. Now we will continue to the kinematics. This is very simple because this is just drag and snap. You hold the control button, and with your left mouse button you can drag it everywhere you want. So as you can see, it snaps in place over here. Same for this one. Same for that one. This one and the last one. Like that. When you prefer to do this manually without drag and dropping, that's also possible. For example, over here I have this from my KUKA robot. And as you can see, these values over here, 350, 210, those are matching as it is right now. And also the angles, you can fill them in over here. Right now it's not necessary to do this because we could drag and drop it and it's already fine. But when you want to, you can do this manually. Now we go to simulation. Looks good to me. KUKA style and apply. Now we will add our end effector. Add mechanism, end effector, and this will be our milling motor. And we will click it as the base, and we have to click base CS edit mode. Then again hold the control button and drag it over there. Now continue to TCP. Now we have to load the robot calibration app on our phone. You have to click for generate QR code over here, and on your phone you say scan and send. And like that, there's our TCP. And here we have it, our robot setup. Now, to finish our setup in Machine Maker, we have to add the base of the robot and the rotary table. We will first add the base of the robot. That's this one. Select it as base and just turn it 90 degrees so it's on the ground. Now we click this, and relative to world CS, we want this to be 0, 0, 0. Now the robot calibration mode, we also want this 0, 0, but I know my base is 600 millimeters high, so 600 millimeters. And now our robot is on the base. Now we have to add our rotary table. Table 1x, but when you have a fixed table, you can also add table fixed, or a table with 2 axes. So we need these files. This is our base. This is our joint 1. This is totally fine. And now we have to define how far my turning table can turn. That's unlimited, but you have to check the turning rotation. So which way is your turning table turning? You can define this by invert direction, and you have to test this on your robot. Also, we have to place this over here. This is again drag and drop. Also there, perfect. And apply. So now we have to define the position of this rotary table. First, we select World CS. Relative to World CS, my table has to be 670 millimeters up. And now it will stay there. And then the positions we have defined earlier, we have to fill in here. So that was 1800.73. My Y was minus 837.97. And that's it. So here we have it, our robot setup completely done. Now we will save it and we will transfer it to ENCY. Here's our robot setup.